record button before I forget to. I want to thank everyone for being here today for this presentation. I want to let you know ahead of time, just keep your microphones on mute. Everyone should be there. We will be recording this and we'll send out a copy of the recording afterward. Can take a couple of days, so just stay tuned to your email for that. And we're very happy that on behalf of the CIS department to be presenting this webinar, and our host for today is Bob Martens. I'm going to turn things over to him and let him get started then.
Thanks, Eric. It is a pleasure to be here. We'll see if the CIS department is still thankful for my presentation. I'll maybe throw them an email afterward and ask them if that is if that invitation still stands, which is all right. I'm just gonna hopefully share the correct screen. There we go. So we're gonna cruise from there. So I was asked to speak on optimizing your data, SQL and NoSQL databases, and so I'm happy to do that. As Eric said, my name is Bob Martens. I've had the privilege of attending and teaching here at the College of St. Scholastica for the past number of years, and that's been a real pleasure to work with everybody to that effect. So like all good presentations, I want to talk just a bit about me, and we'll see if I can speed this up. That's my family. I've got my beautiful wife. We're going to be at 16 years this year, and then our 4 kids. I have my oldest knocking on the door of high school, so I have 1 more year at grade school, and then we're going to have a high schooler, which is crazy for me to think about, but at the same time, I think he is ready, even if his mom and dad are not, to that extent. For a long time, I served as the assistant network administrator here at Martin Luther College. I'm actually on campus right now giving this presentation. And this past December, I moved into the director of IT role here on campus. And it's been a real whirlwind, a real learning curve for me to get used to that. But so my perspective that I'm bringing to this is going to be a little different than it may have been even 8 months ago, as I'm moving a little bit higher up the stack, more into management, and having discussions with some of the more and more of the decision makers on campus as far as about data and those things. So if I'm not getting quite into as many of the technical details, it's because I've been corrupted, and I'm very much interested in my coworker who's outside of my door would agree with me in the synergies, and I always make this motion, the synergies that can be created on campus between decision makers, the data that they have, and those sorts of things. I also have the privilege of teaching primarily online data analytics and educational technology. For data analytics, that's here at the College of St. Scholastica, and then at Martin Luther College, I get to teach in the educational technology. And they just started a director of educational technology program, and I teach primarily IT infrastructure for elementary and high school teachers, which has been a lot of fun this summer to do that. I did attend the College of St. Scholastica. We were one of the last students to shut down the IT leadership master's program. So they thought if anyone like me could get through, it probably was time to sunset it. And then right now I'm also working toward my PhD in leadership from the University of Cumberland. And instead of writing my dissertation right now, I'm here giving this presentation. So hopefully I will be completed and through that program by spring 2023. I think my wife would agree that'd be really nice to have. So at the College of St. Scholastica, I teach 2 courses primarily. So the first is in their Master of Science in Applied Data Analytics. The first is CIS 6105, which is titled Data Analytics for Decision Making. And that is a pretty high level and an introductory look at data, what it can do for you, and how you can work with it. A lot of time is spent in Excel, and a lot of time is spent looking at various data sets, how to clean them up, thinking through the process and those sorts of things, just to give everybody kind of a basic foundation with which to think about data and how it can work for them. Then in CIS 6107, this is usually the second course in this the Master of Science program, is data storage and retrieval. And that's when we get to start talking about the actual nuts and bolts, a little bit more of how data is stored in computing systems, and then how to get it back out in various ways. And that's a lot of fun too. We get a little bit more technical in that one. We get to actually work with database programs and services. We'll talk about that in a little bit. For now, we're going to talk about where are we going. This is our roadmap here for this presentation. We're just going to go and answer some basic questions. Why data analytics? Are databases still important? SQL or no SQL? What is available currently? And then things near and dear to my heart, which is what is Postgres and what can Postgres do for me? And then we'll recap. So that just gives you a very basic cursory look at what we're going to be doing. So the first question is why data analytics? Whenever you're talking about data optimization and then NoSQL and SQL, looking at all those different questions, you really got to go back a step and you have to ask why data analytics and why even worry about data. I know this has been a real pain point for me. My sons don't care at all about data, the data that they have or that they're creating or who it's shared with or where they find it. Most of their answers are, I'll just ask dad when he gets home in those cases. So, but why do we even worry about data? Clive Humby really came up with the idea that this phrase that data is the new oil, and the idea behind that is really that if it's unrefined, it's not worth very much. And so it's through that refining, through the use, through the creation of new things out of this raw resource, that's where the real value of data comes out. That's where the value of oil comes out. I don't stick raw oil into my car. I'm pretty sure I would not enjoy that very much. But it's through the refining of different products. On the farm, it was always very important to keep separate the gasoline from the diesel fuel, because otherwise, if you mix those two up, then you're going to be helping, I'm going to be helping my dad pull apart the engine block and cleaning things up and probably doing an overhaul at that point. So the products through the refining of things can be really powerful. Data analytics, the optimization of data is really an aspect of that refining process into something more useful and powerful. And then that's really the decisions that can be made based on those refined products that requires an understanding of the data. That's where the real power comes out. And a lot of the phrasing that I use is around not data-driven decision-making. That's a phrase that is used often, and it can be understood the right way, but data-informed decision-making. In the end, there is probably going to be a human taking these products, taking this refined data in some way, utilizing it to think more deeply about the subject at hand, and then making some sort of decision that will ultimately affect the direction one way or the other that an organization is going to go. And so that data informed decision making, that utilizing the data is going to end up helping the organization. But there needs to be an understanding, there needs to be some process, there needs to be some optimization, there's got to be some working with that data, because without that, it's just really numbers, ones and zeros in the end. So one of the ways that data is stored is utilizing databases, and are databases still important? Is the storage of data, is how it's stored important? One thing we like to say here on campus is databases may be old, but they're still good and they're still useful. So databases are simply a system to store and organize data. There's a lot of different ways you can do that. Relational databases, which is what we're more commonly used, or probably more used to thinking through, really took over the 1980s, but they're based on concepts that really started way back in the 1960s. It's named after the relational model, and this is common parlance in relational databases, and especially if you look at SQL, which we'll briefly touch on a little bit. The idea of relationships, things belonging to things, or being a child of, or some joining on tables, foreign keys, all those sorts of things, or primary keys, all of those create relationships, but relational databases are based not on that, but on relational algebra, because that's where the basic underpinnings of relational databases lie. It just happens to be a happy circumstance that relationships, how the data relates to other data, is a key component of those relational databases in a lot of cases. So a whole industry rose out in the 1980s around these relational databases, and they're still widely used today, probably more widely than anyone wants to even think about it. As an example, SQLite, which is a relational database engine that's locally stored in a lot of cases, underpins a lot of the record keeping in your browser as far as bookmarks and other data. So in the very bottom underneath all the coding is actually a relational database storing your bookmarks, storing how they relate to one another in various ways. And a lot of programs will end up having backed in some way, some sort of database that's keeping track of something in the end. Even our backup system here on campus stores the individual records for each file that it backs up in a relational database, so that when we're searching for something, we don't have to actually go and find the file. We can look for it in one area and have that information. That's a data optimization in that case, by storing information about where the data lives somewhere else so that you can easily find it in a faster way over in a different location. Just kind of an interesting way they handle things. One thing databases do, and every one of them has this to a greater or lesser extent, is that they help maintain rules about the data that's stored, helps to verify the data. And in those cases, it narrows how a programmer or a developer or a researcher needs to think about how am I going to access the information that's stored within this database system. Even the most, I was going to say least robust, but even the most flexible database system is going to have some sort of rule set that it follows and that it requires the programmer to follow, requires the data itself to follow, so that it can reason about the information that it's storing. And one of the key terminologies around optimization is normalization. And it really is, there's a lot of different ways to handle it, but within relational databases specifically, but in other cases too, it's the structuring of data to reduce redundancy. So if you store a certain piece of information in multiple areas, it's rife for there to be inconsistencies across how they're going to be recalled in certain ways. So an example of how that would work is if you have billing codes within your financial services package and they don't store what all the billing codes are, but just require the person to input them accurately. If you input them inaccurately, you could get bad data coming out, a bad analysis or bad information, bad reporting come out the other end. So database normalization would take all of those maybe hand-coded ones and say, really, these are the canonical ones, and we're going to create some sort of connection back to that so that it can create consistency and normalize that data. So it's not, first of all, being stored multiple times, and it can also be more accurate that way. And through that accuracy, you're able to gain performance improvements and those sorts of things. So that's a very cursory look at database normalization. One of the best books I've ever read on database design and normalization is called Database Design for Mere Mortals. And don't let the name kind of turn you off, because it's like the Database Design for Dummies or something like that. But it's a very in-depth look at logically thinking through how would you structure a database to store certain types of data, and then normalize data that comes in and pull those things out. It's a really fascinating book, very easy to read, and can be very informative and helpful when you're trying to reason about the data that you have and how you might be able to store it inside of a database system. Okay, so databases are still important, or at least to me, they still are. So now we're going to talk about SQL, or beyond SQL, that other group of database systems and query languages that are outside of SQL. And SQL really stands for structured query language, and it is a domain-specific language for relational databases, which means it's really meant to help to pull data out and put data in a lot of cases, but just to work with data within relational databases. And so this structured query language has borne up out of that entire branch of computing and theory and those sorts of things. So it has some limitations inherent with that. It is now, SQL is an ANSI and ISO standard from the 1980s. So that's when you could see the same thing. Relational databases coming out of the 1980s. SQL was standardized already back in the 1980s, and it continues to this day. The latest release is SQL 2019. The way that these standards usually work from a product perspective is that the products that utilize SQL will lag behind a few versions from where the standards are being defined. So we'll talk about it a little bit. A database engine might only implement SQL 2011 as the standard, even though they're on 2019. It takes a while for everything to work its way through, but 2019 was the last time. So it's still being actively worked on and actively developed even to this day. The last three were 2011, 2015, 2019, and I think they're working on, might be 2023. Due to COVID, it might actually be pushed to 2024. I didn't look specifically at where the ANSI and ISO standards are right now. The SQL, the structured query language, that domain-specific language for relational databases is made up of a number of different things. Clauses, expressions, predicates, queries, and statements. They all have a specific purpose. You combine them in different ways in order to, like it says, query or ask the database to give you answers to questions is what you're ended up doing. You're supplying what you're looking for, and it shoots back what it thinks it has based on what you're asking. And so that's why you have clauses, expressions, predicates, queries, and statements. So SQL, standardized, very much let's not say slow because that sounds negative, a deliberate process of improvement over time. It is a known commodity. There's a lot built up around it. There are a lot of tools built up around SQL. There's a lot of support around SQL as a language, even if there's some weirdness around other aspects of it. But that is, the structured query language really is a known thing and works with relational databases. On the other side, you have this no, non, beyond SQL. It comes by a lot of different terms. NoSQL is kind of the catch-all. But as you can tell, it's actually an entire class of database systems. SQL is a query language specific to relational databases. When we talk about NoSQL, it's not a query language. What it means is that this database engine is not really built to use SQL as a query language. So in those cases, a lot of times it means it is not relational, but they usually have their own query language specific to that system, because if you have SQL for relational databases, it's a one-to-one mapping in those cases over here. And then you have something that's called NoSQL. That's a very big thing that can happen over on that side. There are a ton of different things that can happen. So a lot of times you have a certain database mapped to a certain query language. So there's just a lot less structure, a lot less standardization, a lot more specific domain languages being created to handle specific problems. And because they're called NoSQL, it's explicitly not relational in nature. A lot of times they are being created and being used to try and answer a specific challenge that SQL and relational databases have in those cases. So it's not that they can't do it, but that there's a challenge around utilizing a relational database. And so you have a response to that in the creation of a different system. And then because that system needs to be able to get data in and out, you have the creation of another query language. Now there is always, as soon as you have a proliferation of different systems and different query languages, there is work to try and narrow those down. There's entropy that different systems come and go, but it still is very much, when you have something that is just not that, by definition, you've got everything else over in this other category. And then I think I mentioned this before, created to solve a narrow use case, and unlike SQL, it's not usually controlled by a standards body. And so you end up using something that doesn't have the same deliberate nature to it. A lot of breaking changes can be implemented. But again, these, you know that going in ahead of time, you're trying to solve a specific use case. So the question is, which one is better? And the answer is neither. Neither one of them is better. They're different. So both are better. And it really comes down to, you're asking to look at the right tool for the right job. And this goes for anything in computing, really. If you're going to look at programming languages, if you're going to look at operating systems, if you're going to look at specific software packages, if you're going to look even at programming language paradigms, if you're going to look at imperative versus functional versus object-oriented, all of them are a right tool for the right job. You're never really going to get a really clear case of which is better until you start looking at what job are we trying to solve? What challenge are we trying to meet here? So it's a right tool for a right job. So what's available? And it really is a sea of options. to me, the easiest is always to talk about the relational databases because a lot of times they've been around for a very long time. MySQL, which I think is owned by Oracle now, it really came to prominence in the late 90s, early 2000s when the web was taking off and they needed to store data. And so MySQL was an easy database system to get started with. And so it's continued this day. Again, relational, it has SQL in the name, so it's kind of obvious about which way we're going with this one. So MySQL, Microsoft SQL, again, in the name, it's a relational database by design, but runs on Microsoft platform. Actually, now it runs on other Linux platforms too, so they've kind of taken some of those restrictions away from it. Oracle has their own database product that they use as well. And then PostgreSQL, again, in the SQL name. So all of these are in the same category. A lot of the same SQL syntax that you would use for the structured query language in order to work with the data that's there is going to be applicable across all these different platforms. Now, in each case, there are going to be small to medium-sized differences that you're going to have to navigate. Web developers have been dealing with this for a really long time, depending on which driver you have to use. Sometimes there'll be some translation that's involved. They've created this whole industry around ORMs, or object relational mapping software, that allows you to, and obviously the hope is always that you can write the same code and then you can just change the drivers out underneath and use it on any database system. That usually doesn't work as well as people hope it would actually work. But the same concepts apply because they're all working from the same database paradigm, and that paradigm is relational algebra and utilizing SQL, or a very close SQL, very, very near the standard SQL syntax in order to work with the data. And so you can usually hop around between these pretty easily. Document stores, and actually document stores beside these two that I have here, a document store could be as simple as having a flat file that you read lines off of. If you wanted to get crazy about it, a CSV could be considered a document store because you could read and write data from it. It's just storing just a document. CSVs are a little bit different that way, but MongoDB is really well known. I know of I've run into MongoDB in a couple of instances in our infrastructure when we're wanting to store logs. A lot of times will be stored inside of something like MongoDB. Very much documents. Databases are super flexible. They don't a lot of times have a schema attached to them, which is a set of rules around how the data has to live. They are infinitely able to compose themselves and add and remove components to how they store data because of you're just in the paradigm they're working with. Each individual record is kind of its own little kingdom that it lives inside of. And then a lot of times the structure will be maintained by the programming outside of it. Now, there are some tooling around these database engines to do schemas, but in the end, the idea is to make them as flexible as possible so they can meet the needs, the ever-changing needs of fast-moving organizations, or in the case of something like MongoDB, be able to ingest changing log files and then query information out of that over time. For us on campus here, we utilize a wireless system from Ubiquiti Networks, and we have a server that sits and collects all the log files. And on the back end of that is a MongoDB database. And so when I'm interacting with their GUI console to read what's going on, what I'm doing is having the program query that MongoDB database and read out the information from there. Elasticsearch is used a lot of times for full text search. We have a Graylog server, which centralizes logging that is backed by Elasticsearch and ElasticDB, and that allows us to do, again, Elasticsearch is really there for full text searching. And again, super flexible because you could just search text. So that's the problem they were solving, is very fast, very customizable, very accurate full text searching. Elastic is going to be your thing. For Mongo, very fast, very flexible document structure. MongoDB is going to be your thing. In both cases, if you have a relational database or relational data in general, you're not going to be storing it inside of those. Key value databases like Redis or React are used often for I think in both these cases, one of them stores their key value pairs in order, and one of them does not. And so the intent is to quickly be able to create queues. So something like Redis is often used as a job queue, a very fast job queue for different systems. So you'll be able to pop things on and pop things off in order and maintain that order and query through those things over time. So Redis and React are key value options databases in that way. I put this one up here just for my own sake. Back when I first started after college, I was working with a content management system called Plone, and they used on their backend a ZOP object database. And the cool thing about a ZOP object database is that it stores serialized objects from an object-oriented programming language. So you get to store an object in an object way, and then use all of the same programming interfaces that you would to get information to and from. It was kind of a weird way to do it, but it was, again, really flexible with how you have data interact with other data if you're working within an object-oriented approach at that point. Definitely not as popular now. It involves a whole bunch of complexity if you're really just trying to work with data as data and you're not trying to work with it as objects. So again, it's one of those things where the right tool for the right job. If you're working with objects in an object-oriented nature, this might be something that could be useful, or a similar database, an object database. But what's ended up taking its place a lot of times is something that is flexible like MongoDB. You can just serialize objects into a document, and then you get all of the benefits of having it stored as a document and can interact with other things and not have it stored in an object database. So there's some workarounds that way as well. And then graph databases, the big player in that space is Neo4j, and it just stores the relationships in a graph form within the database, and that's its whole thing. So there are some data that really works. I know a lot in research, especially I think in biology, they use a lot of graph databases. So there's certain types of data that lends itself well to a graph paradigm as far as how it thinks about the structure. And so a graph database like Neo4j would work really well in that instance. So you just have a whole bunch of options. You can see relational is very well, right now is very mature. Those products up there are extremely well supported. They've been battle tested. They are used by the very biggest names in the internet and in computing in general. I'm just trying to think of who did I just hear had a really large Postgres database. Maybe it was Square or Shopify, I think, had started on Postgres, as they have a multiple petabyte Postgres database that they moved. It was one of those players in the financial space, had to do a migration. So they were talking about everything they had to do to migrate to a new version. And a lot of times too, they'll have more support available, and then just the options of where it's hosted is more available as well. Some of the newer ones have gone through in their communities a little bit of turnover because they were not making enough money, or they felt they weren't making enough money to be sustained in the long haul, so they've changed some of their licensing terms. So that's something to watch out for as well when you're looking at different database engines, is what are my licensing terms like? When can I and can I not use it? And how can I have users interact with it? We'll talk about licensing specifically in just a little bit for that. So I'm going to speak a little bit about Postgres, and the reason about Postgres, I want to speak about Postgres specifically is because I think it's really great. The other part of it is that in CIS 6107, we talk about data storage and retrieval. We actually utilize Postgres as our database layer for when we're interacting with data, putting data in and pulling data out again. It is a popular open source database engine. And when I say open source, I'm specifically talking about the license that Postgres is released under is a very liberal license at that point. And hopefully I'll get to that in a little bit. Postgres itself dates back to the heyday of relational databases back in the 1980s, and came out of a project at UC Berkeley called Postgres, all in capital letters. So they've kind of rebranded at the time, and now they're PostgreSQL. Everyone still calls it Postgres. right now as well. It is platform agnostic. So Postgres, you can run on Windows, you can run it on Mac, you can run it on Linux. You could probably run it on your phone if you really are adventurous. There probably is some guy out there running a Postgres distribution on his Android phone. I'm not sure if you can run it on an iOS device. That'd be a little dicey, but it's platform agnostic, so you can run it on almost anything. And the cool part is it has very liberal licensing. Postgres does not have a lot of restrictions around what you can and cannot use it for. So you have no restrictions around the number of users who can connect. You have no restrictions around how many queries you can attach to it. Those restrictions are purely technical and not licensing based. So some of those things fall away, which can be really helpful. However, there is paid support available if you need it. Enterprise DB is kind of probably the cream of the crop as far as paid Postgres support that's available right now. And they also offer implementation stuff and those sorts of things as well. But the base Postgres system, along with being able to run on all these different platforms, that is available via open source. If you have either the technical know-how or the willingness to give things a try and see how it works, Postgres is going to kind of be the thing for you. Postgres is very reliable, hence why the elephant is kind of their mascot. The community very much is almost fanatically so interested in not losing any data. And there was a time in the NoSQL space specifically where some of the distributions, some of the systems got a reputation for not caring about data. Now, that isn't necessarily wrong. In the case of something like MongoDB in certain setups, if you're most interested in speed and you really just want to ingest the most number of documents that you can and store them as quickly as possible, you may give up, and we go right back to the right test for the right job. And this is the optimization part. If you are optimizing your data and your setup for speed, storing the most amount of data as quickly as possible, and if you lose a certain percentage, that's okay, because the workload that you have and the analysis you're trying to do really just needs amount, not that you have everything, but that you have enough of it. Then there are setups like MongoDB in certain instances where you are going to give up a little bit of the reliability, a little bit of that, the elephant never forgets part, in order to maintain that speed and the ability to just ingest as much as you can, as quickly as you can. Postgres, however, falls on the other side of that category. In certain instances, it does give up a little bit of performance so that it can be reliable, that you can have confidence that when a transaction, which is what they wrap every SQL statement inside of, or any work that's going on with the database, they wrap it inside a transaction, that when that's done, you can have some confidence that it's actually going to be there the next time you look. That's where Postgres, the community, has fallen in those instances. And then what they've done is they've backfilled some of the performance. So one of the big things for on campus here, what we did is when we moved from a very old version of Postgres to a new version, we picked up parallel queries and then parallel indexing so that we could actually utilize multiple processes to speed that up. That was huge. Now, other database engines that had that for a long time, but we picked it up finally. They're backfilling some of these performance things. So another one of those optimization things, another place where the right tool for the right job is important. You have to know what data you're storing, why you're storing it, what you want to get on the other side, so you know what trade-offs am I willing to make. The other thing PostgreSQL does is it follows and supports the SQL standard as closely as possible. So right now, they consider themselves to be compliant with SQL 2011. Like I said, there have been 2 releases since then, and they're working on the next release at the ISO and the ANSI level right now. But they are, again, fanatical a little bit, but they pride themselves on their support of SQL as a standard as closely as possible. And then they do layer on top of that some additional pieces of non-standard things as they're working through, but then they do go back and they do support the standard way of doing stuff. And a good example of that is Postgres offers tooling around not just relational structured data, but around unstructured data as well. And one of the ways that Postgres is non-standard right now is they have a binary JSON format that they store and work with that allows them to do things like indexing and querying unstructured JSON right next to the relational data that you have stored in the regular, in the normal, I'll use normal in quotations there, Postgres tables, so you can kind of get a best of both worlds sort of thing. So, but that's an example of they're extending out from the standard as they're working to support that SQL standard as closely as possible. Now, a cool thing in the core CX 6107 is that students who come in and in their place of work, they work with MS SQL or they have an Oracle database that they're working with. And we've seen this in a couple of instances. They are able to take the same concepts that we're working in SQL and apply that to those database engines and still be able to do data analysis, even though they're not working specifically with Postgres in their place of employment. But Postgres, their liberal licensing allows us to not have to buy licenses for students to be able to use Postgres. So it's kind of a win-win that way. And if I would say so myself, I think Postgres is the superior database engine, but that's just my opinion in that case. So the question is, what can Postgres do for you? And I've talked about Postgres as the solid foundation right now. And this is really databases in general. So, but Postgres specifically, the community prioritizes reliability and storing your data consistently and safely as a priority. One cool thing is many cloud providers, this gets outside of the open source nature of it. Many cloud providers like Amazon and Google and others offer managed hosting for their Postgres database. So one of the things we do work on in 6107 and can be useful for any organization is we use what's called Amazon RDS, which is Relational Database as a Service. Their SaaS version, if you want the software as a service version of Postgres. We spin up our own instances of that RDS instance in Postgres. We connect to it from a machine that is not co-located with Amazon's web services with where it's located, and then we interact via SQL, and I'll talk about the GUI toolkits in a minute, interact with data, both storing it and retrieving it without ever having to actually load Postgres on your local machine. It's all stored up in someone else's servers. You interact with it where you are, and that is a common way that data analysis is conducted. Whether you're connecting through R or Python or anything else, you're usually not storing all the data on your local machine. You're connecting via some sort of tool or driver to do so. So we try and recreate that sort of scenario as closely as we can. And the cloud providers supporting that allows us to be able to recreate that. There are a lot of GUI tools and toolkits available for working with Postgres. And this goes for really any database. Obviously, Microsoft and Oracle have GUI tools for investigating and managing their databases, and then also querying and those sorts of things. Plus, they have integrations through things like Power Query and other things, so you can dump directly into Excel and other things, which allow you to have a lot of flexibility around how do you use your data. But even Postgres has what's called PG Admin, which is an entirely GUI-based way of managing your database setup. They switched to built on web technologies one, so it's a little clunky sometimes, but it works really well, and we use that often. Here at Martin Luther College, one of the GUI tools we use is called dbeaver, because DB, so they like funny, cute names sometimes in the communities for their different tools. And that's just another graphical interface for doing queries. Now, dbeaver is not specific for Postgres. It can also work with MySQL and other relational databases. But it's an example of another open source tool that can allow you to not have to work exclusively on the command line when you're managing databases, but be able to use a toolkit that's meant for querying and getting data and testing things out that way. It can be used for a lot of different workloads. Postgres includes the ability to be used as a queue. We talked about things like React and Redis, which are key value stores. You can do similar sorts of things with Postgres. One of the things Postgres is best known for is the PostGIS project, which allows GIS data. And I don't forget what the name of it, but it stands for. Shoot. Well, GIS data. So I interact with it mostly when I'm looking up how much my taxes are going to be for the current year, or to see how many square feet they think I have in my house. But you can store GIS data inside of Postgres, and there's a whole project around it that way. Postgres also has a facility to do full text search. We talked about Elasticsearch. They can do full text search, which is kind of a cool thing, and set up custom ways for Postgres to reason about the text that's there. That is actually something we include in CIS 6107. We include working with text, full text search. And actually we look at it, I think in the past we've always used presidential speeches. And it's kind of funny to see how different presidents, how long or short their speeches are, but to kind of pull out different words, different phrases, see how often they come up. And through all of that, you can utilize those facilities to help people and to reason about the data that they have. So Postgres has some of that. Another thing we already talked about is the ability to store JSON and unstructured, unschematic data. So data without a schema in various forms is super flexible within Postgres itself, and utilize querying that data right next to relational data, so you can get the best of both worlds. An example of how that might work is you have all of your user information that's denormalized, that's normalized, and everything is clean and set up. So you have one of it and only one, and those sorts of things. And then you have stored over here a dump of say their some unstructured data around survey information that they provided for you when they entered onto campus. And you can then change this survey data over time and just continually store a copy of that data over time, but you don't have to worry about this ever being unstructured at that point. So by able to split what the best structure for the data is, you can optimize in different ways. In this case, you're optimizing for the speed of updating that survey, and so you can keep it updated over time and add and remove sections. And on this side, with the relational data, the user information, you're optimizing for correctness, and because you have reporting that needs to happen across those lines, and if you don't have correct data, that can be a big issue for the organization. There's also a lot of drivers, different drivers available for Postgres around almost any programming language you can think of. R, Python, Ruby, .NET, so C++ or C#, I'm sorry. RStudio as a GUI has hooking up through R allows you to query Postgres databases and query remote Postgres databases. Microsoft Access through ODBC drivers allows for the querying and the use of remote Postgres databases as well that way. We use that extensively here on campus. Excel through things like Power Query and other options allows you to directly query Postgres databases and get information out that way as well. So you can actually pull live data out of a database, put it into an Excel spreadsheet, and then work with it from there if you have macros and other things that need to be run. Pentaho, there are just a lot of other data analytics platforms. Almost every single one of them is going to connect to a Postgres database, along with a myriad of other options that are available out there for you. That was not always the case, but it definitely has become the case more so in the intervening years. If you back up to my time as a student worker, when I was spending my time not helping the students that I needed to, but more time trying to learn Ruby and Ruby on Rails. Postgres was like a third-class citizen at that point, but now it's fully supported in a lot of different ways. MySQL has kind of been there the entire time, but Postgres has really gained speed in the intervening years, which has been really cool to see. And then I already talked about this a little bit. Allows both the structured and unstructured data to live next to each other. It allows you to optimize both your schema on the structured side for the data you need, and also optimize for unstructured data too in those cases. Again, the right tool for the right job. Sometimes it's nice to just be able to dump a whole JSON blob into your database and then query it, because you don't want to have to think about how you're going to normalize something that is not really normalizable in those cases. And we use that extensively for archiving data. In case we would need to use it, we can just dump it, store it in the JSON, as a JSON-B field, which is a binary format, so it's faster and allows us some additional things. And then if we need it, we can work through it, but otherwise we know it's going to be there because it has all of that other reliability and comfort that Postgres offers sitting around it at the same time. So it's kind of cool. So just to recap how far we've come, we talked about why data analytics, the importance of data-informed decision-making, how data is the new oil to an extent, that it needs to be refined. Raw data is has very little use as just raw data. And it's through that refining process that we finally do get to something where we can inform decision-making and help us to make better decisions in a more timely fashion. Ask the question, our database is still important? And I think I would fall in the category of yes. Every person needs to make their own decision at that point, but definitely databases as a paradigm, as a way of storing data, as data becomes more important, a lot of times just the rules and the way that the data needs to be stored has a benefit for organizations because it allows users and people who need to have it some way of reasoning about how can we use this. We talked about SQL or NoSQL, and I think we came around, it's not an either or, it's probably both and it really depends on what job needs to be handled, what challenges you have, and what trade-offs need to happen so you can get the job that you have done. We then talked a little bit about what is available. There's a whole slew of things in the entire industry right now around both on the SQL side and the NoSQL side. And increasingly there's cross-pollination between the two. So your SQL databases like Postgres are gaining a whole bunch of facilities of NoSQL databases have. And on the other side, they're kind of the NoSQL databases in some instances are backfilling in some SQL-ish stuff around even sometimes allowing query SQL to be written against their data store, which is an interesting optimization. I think it's important to always keep in mind that there are still going to be use cases, even though I might reach for something like Postgres often, there are still going to be use cases where, because of the job need to be done, a tailored solution is going to be the best option. So if you really need to have a queue of jobs and keep track of it and do it fast, something like React or Redis is going to be a really good use case because it's just going to do that job better. We then talked about Postgres coming out of the 1980s from UC Berkeley, how it's open source, the liberal license, some of those, what the elephant even means to an extent, and then what Postgres can do for you or for me, how it kind of is a best of both worlds at times, but it's really interested in rock solid reliability. That's where it becomes down to. And it enables users to optimize their data and optimize how they store it based on the needs of that specific application or even that specific part of an application, which allows for just the best use of that data over time and for people to be able to reason about it as easily as possible. And now we're here at the recap. So with that, I'm just opening it up to any questions or comments. I can try and answer things that I can, and then leave open those that I can't to maybe follow up at that point. So, and I'm watching the chat too, just for the record.
Yeah, I would say feel free to unmute yourself or drop the questions into chat.
I can go if there's nobody else has a question. I was wondering, so of course, right when I got up and I got a cup of water, and I missed what you said about graph, or I caught the end of it. But I was talking to, it was the director of IT at the Minnesota court system earlier this summer, and he was saying that graph is really something he looks for like in job applications, and
Sure.
as somebody who's got graph experience. And he was saying that he's seen a lot of people using graph, especially people that have a lot of data, and using that to tie together multiple databases and looking for people who have got that graph experience. What have you seen about graph databases, or do you use them at the college? Or
we don't use graph databases at the college at all, but I've heard similar sorts of things. A lot of times if anybody on here is talking about them, it's usually in a research context. And we had some person who was working at the U of M, I shouldn't say with the U of M on his degree program. And they, in their biology area, they were working specifically with a graph database at that point, but they were pulling together specifically in hybrids for the corn and looking at herbicides and stuff like that. So just the data itself was formed in such a way that it was structured that way. But my hypothesis, and the little bit that I've talked with other people here and I've looked at it, I think the excitement around things like machine learning and AI and wherever you fall in those categories and stuff like that, but all of those sorts of advanced machine algorithms and stuff, they assume a little bit more of a graph way of thinking in some instances. And so that kind of lends itself toward a graph database. And Neo4j is kind of on the open source side is kind of the one at that point to do that. I always, whenever I think of it, I just can't get the picture out of my head. I always think of like Star Trek Voyager and how they had like neural computers. I'm like, that's really kind of interesting. So now that we're talking about, one of my colleagues took an AI programming class and he was talking about how he was supposed to be looking at it. And I'm like, oh, okay, so that's where we're at it. Well, hopefully we don't have quite the same thing, but yeah, that's where I've heard it most. We don't use it here. To be honest, our data sets are often highly relational is what we're working with at our college. We don't have a heavy research component. And if it is, it's a lot of times very qualitative in nature. And just because of the narrowness of our programs and stuff. But that's our weakness. Postgres fits our needs in that way really well, just because we're highly relational as far as the current data that we're storing. And then we've tacked on this JSON stuff on the side in a lot of cases when we had to do integration pieces. And that's how we've handled the integration part.
Hey Bob, this is David. Mark, I have a kind of a similar question to Chris related to graph query and the graph kind of language and structure. So Eric Nordgren and I, we went to the HIMSS conference, and Eric, you might remember this, where we had a really intense guy come up to us and asking us questions about graph querying, and he was I don't know, a salesman for Tiger Graph, which is yeah. Anyway, he was talking about it more as like a method that would totally substitute SQL.
Sure.
What do you think that is a bold statement, or that's reality?
Yeah, I guess I would have to do a little bit more thinking to see. I do think it's a bold statement to say it's going to completely supplement. But part of that is probably just my bias coming out more than anything else and recognizing that piece of it. Graph has a lot of, I mean, it's gotten some legs too from even Facebook's work as far as the social graph is concerned and trying to figure out where the connections lie at that point. And in those situations, I think it would. But the hard part of my mind, and I probably just don't know enough or worked enough about it, is I still feel that there's some benefit to being able to reason about a system as a fallible human brain, to have some understanding around that line. And that's, again, my fallibility and my bias coming out. If things get too complex, it feels like we're losing the ability to really make good decisions, because ultimately we're just subservient ourselves to whatever the thing's going to say or put out at the other end. But so that's where I'm like, the beauty of structured query language is that it's kind of like question and answer at that point, but it's not human readable. So that's the way it was presented back in the 80s when it was coming out. It's going to make it so that any person could write queries to a database, and we found that to be not the case necessarily. But you can think about it as a human would think about it, and think about it as this is how a human needs to ask a question of the computer. Some of the graph stuff to me seems like it's more like we're asking a computer the question like we would a human, and hoping it's going to give us something that we can actually understand and make actionable. Or we're putting it out there in the hopes that we're going to get something back. I mean, that's my uncomfortableness. But again, I don't know enough to really make a real strong.
Yeah, I appreciate your insight. That was a very similar conversation that we had, that we were like, I don't know about that. But I also think it's also my bias in healthcare, that things do tend to move at a different pace where we're
Right.
steps and steps and steps. We're working in transactional systems when we may not need to be, and so
Yeah.
I think that's where some of my bias comes from with that as well.
Well, I think in education too, we end up doing the same thing because that's
Right.
we're a teacher college, and I see Perry's in here, and so he can probably empathize with a couple of things that I would say. That instance, we are slow and deliberate, and so in a lot of the cases, from a technology standpoint, I'm probably slower than maybe some others because I know I need to bring people along just to get to the point where they're comfortable with like the last paradigm, and then trying to leap over to the next one. It's
Right.
like you're going to completely lose a whole, like the benefit at that point, because they're either going to completely discount whatever's coming, whatever technology use is there, or they're just going to trust it implicitly and not be intentional about it. And trying to foster that intentionality is key.
I have zero experience with graph query language, but I wonder how similar that is to SQL in terms of transferable skills with some of our graduates that are coming out of these programs too.
I'm going to leave a note for myself.
Yeah.
To investigate that further, because that's
because to your point, Chris, about that people are looking for that on the resumes. Well, maybe SQL, they can learn those skills on the workforce. It's the fact that they know SQL is very important,
Chris, if I may just ask you a little bit further, what industry were they primarily working
So
from?
he works for the Minnesota court system, but he came from Mayo. And so he was working with a lot of healthcare data. And so he was saying that it's a way to just normal database querying is too slow over that amount of data.
Right.
So it's a way to cache things, probably in the cloud, and to speed things up with that amount of data.
Sure. And then I wonder, when you mentioned Mayo, I wonder what kind of data it was at that point, if it's like patient data or if it's research data. Because that might make a difference too, because of how it's stored and what information they're actually trying to go out across. Might make a difference too.
I got a lot of thoughts.
I got a lot of thoughts going through my head. I'm sorry. That was more spitballing on my part. Sorry, just taking a note there.
Any final questions here? Well, thank you again so much, Bob. I think that this was a great use of an hour here, and I'm looking forward to being able to share this with other folks. I know that we had some drop off during that. So, and we're hoping to offer more of these for those folks attending throughout the next school year. Stay tuned to our professional development page for more information.
All right. Thanks everyone for attending.